Today I thought I'd talk about a trait in particular and a point that I think is it's kind of obvious, but it's also interesting to me. And that is that traits can be more and less abstract depending on the way you use them. And so this example here is this connection trait, and you can see it's so when you have a trait, you use a trait when you want a whole bunch of types to follow the same behavior, and you can see connection. You have this this trait here, and it has these three methods that are not defined, so you have to write these out yourself whenever you implement. And the rest of them, they have these default implementations, so you don't have to write all of this. And so impl connection, and then you can see that throughout the code there's a bunch of so there's like native, and this lets you decide at runtime what kind of connection you're going to use. And so you have that, and then you have like native DB, and you have WASM, and so on. And so they all have a little bit different behavior, and so that's why they're implementing this trait. And so the interesting part to me is that sometimes you start out with something really concrete in your code, and then you decide, you know, I need to turn this into a trait. And when you turn it into a trait, you think, okay, this is a trait now, and everything needs to be super abstract. And then you get to this is from Axum, not SurrealDB, but you get to this like really sort of abstract, like so you've got this needs to be a trait, and that needs to be a trait, and because you don't have like, there you go, you've got state, and this is also something generic, and it's it turns into like really abstract. And that's what you want to have for a library, because other people are going to use it, and so you want to have everything as generic and abstract as possible. But if you are just using a trait for your binary, and you have inside your binary, you know it's going to need these concrete types and so on, then you can just stick concrete types into the methods. And I'll show you where that is. So let's get to connection again, trait connection. So this kind of makes the trait semi-abstract, but also largely concrete. So you can see, so connection, so it's got this this method. This is a concrete enum. It's got an address, and that's an endpoint, and you can see that's a struct, and capacity, that's a number. So you do have, what you can do is you can put these references into all these concrete types, and then you do have access to that, because when you have a trait and you just have a self, you have no idea what kind of fields does it have. You have no idea, but if you put these concrete types into the function signatures, then you can keep that concreteness. And that's fine for binary, because nobody is going to use this trait for their own libraries. Nobody's going to do like cargo add SurrealDB core, because it's a binary, it's not a library, so you can't do that. And then you get to go into like router and so on, and then you have all of this this concreteness here. So yeah, that's one easy way to keep things semi-concrete, and then you don't have to do like for example, router. Like if you wanted to make this really abstract, you would think, okay, I'm turning this into a trait, so this needs to be like impl router behavior, or param needs to be like a into param, impl into param, and then you have all these things. And then instead of a router, you'd need to do like let's see, self-send router, you need to do like a router, I don't know, into value or something, and you would need to have router implement all these other functions, and then it gets a little bit hard to follow, especially when you're just putting together your own binary. So it's kind of an interesting like middle sort of behavior when you have a trait. So you don't always need to go like totally concrete, totally abstract. You can have like a combination of both, and have like a middle ground depending on what suits you best.